Today we'll be talking about 3 indices, huge mistakes that I see all the time. And by the end of this video, you'll know some really handy tricks so you don't fall foul of these traps too. The timestamps will refer to when we talk about mistakes for numbers in index form revolving around multiplying incorrectly, dividing incorrectly, and being unaware we can attain the same power. It's Rami here, I'm teaching today's video, so let's get into it. Common mistake number 1. Multiplying or dividing numbers written in index form incorrectly. Let's look at 2 to the power of 3 multiplied by 3 to the power of 2. In this example, if you want the number in index form, then this is it. This is the answer in index form. No further action required. However, let's look at a classic mistake that students make. Some students may go ahead and multiply the bases of 2 and 3 together to make 6 and add the powers to make 5. Giving us 6 to the power of 5. Creative. But it's pretty easy to show why this doesn't work. By writing out the long form of these numbers in index form out, 2 to the power of 3 is simply 2 times 2 times 2, whereas 3 to the power of 2 is 3 times 3. Whereas 6 to the power of 5 is 6 multiplied by itself a total of 5 times. Now, just comparing these expressions, it should be very clear that these expressions are clearly not the same. Alternatively, if you grabbed your calculator, you would notice that 6 to the power of 5 is 7,776, whereas 2 to the power of 3 is 8, and 3 to the power of 2 is 9, and when you multiply these latter two together, you get 72. Yeah, so that didn't work out so well. So the lesson learned here is that the multiplication rule of indices only works if the bases are the same. However, you may be able to multiply or divide some numbers in index form by manipulating the expressions even if the powers or bases are not the same. Although this wouldn't be the case in our particular example, we'll talk about cases that do work. Common mistake number 2. Multiplying or dividing numbers written in index form incorrectly when they could have a common base. Let's try one with some algebra and division instead. Like the previous example, students may make the mistake of thinking that we can just go right ahead and just divide the 4 and 2 to get 2, then subtract the x and the y to attain 2 to the power of x minus y. On the other hand, some students may say, not possible. The bases are not the same. Well, not quite true. Let's have a quick chat as to why. Although it is true that since the powers and bases are not the same, you can't directly divide these right away, and despite the fact that it won't be possible to make the powers the same immediately, 4 can be written as a power of 2. By attaining the same base, we will be able to use indices laws further down the road. So we could rewrite the expression as 2 to the power of 2 all to the power of x divided by 2 to the power of y. I'm now going to use the power rule of indices for the numerator, and I'll write the rule on the side. As per the power rule of indices, 2 to the power of 2 all to the power of x is the same as saying 2 to the power of 2x, since we can just multiply the powers together. Since we now have these two parts of the expression having the same base, we can now use the division law of indices, which I'll write on the side. 2 to the power of 2x divided by 2 to the power of y is just 2 to the power of 2x minus y, since we can just subtract the powers. In the end, we were able to bring these terms together despite the fact that they originally didn't have the same base. So the lesson learned here is whenever we are multiplying or dividing numbers in index form, if the bases are not the same, see if you can attain a common base. In the last question, we could only bring those numbers in index form together because each number could be manipulated to have a common base of 2. Let's look at a case where we can multiply or divide numbers in index form even if the powers and bases are not the same. Common mistake number 3. Multiplying or dividing numbers written in index form incorrectly when they could have been written as having the same power. Let's try this one. Again, a classic mistake here is to divide the 3 and the 4 then subtract the 6 and the 2 to attain 3 over 4, all to the power of 4. In a similar manner to the last two examples, we can't do that. But there is a way to bring together these two terms. I can't write 3 as a power of 4 or vice versa in a convenient manner like we did in the last example. However, I might be able to manipulate the powers so that they are the same, especially bearing in mind that 6 is a multiple of 2. In fact, we'll use that knowledge to our advantage. Looking at 3 to the power of 6, I'm going to rewrite the 6 so we have 3 to the power of 3 times 2. I'm now going to use knowledge of the power of the law of indices, which are right on the side. So when we have a number written in index form, all to the power of something, we could just go ahead and multiply those powers together. Using this knowledge, 3 to the power of 3 times 2 is the same as saying 3 to the power of 3, all to the power of 2. So for our next line of work, we can rewrite this as being 27 to the power of 2 divided by 4 to the power of 2. I'll now write the following rule on the side, which is that we can use the fact that if we divide two numbers of the same power, we can then divide the two bases together and then set them to have the same power. More pertinently, this is like saying a over b all to the power of n is the same as saying a to the power of n divided by b to the power of n. So this means for our final line of work, we have 27 divided by 4 all to the power of 2. So the lesson learned here is whenever we are multiplying or dividing numbers in index form, if the powers are not the same, see if you can use the indices laws to attain the same powers. So that's going to do it. I hope you managed to get something out of today's video. Don't forget to subscribe for more free content just like this, and turn on all notifications so you don't miss any uploads on this channel. If you have any questions, just pop them into the comment section below. Thanks for watching, and I'll catch you in the next video.